Well, hello and welcome to this exercise on probability, recurring decimals and two dice. It is a higher tier GCSE question and therefore should be suitable for iGCSE and 10th grade algebra. Right, now we have two dice here, a blue and a green dice. Okay. Now the whole idea is to generate a fraction based on the to create a fraction based on the numbers generated by these two dice. Now for instance, we got 6 there and we've got 5 there. 6 over 5 will give us 1.2, and 1.2 is a terminating decimal, so it stops there, it doesn't go on and on and on. Okay, so the questions are, for the first one, if you roll both dice, that's one event. If you roll both dice once, what is the probability of getting a recurring decimal? And the second question says, if you roll both dice twice, in other words, you got two events, what is the probability of getting a fraction giving a recurring decimal at least once? Now, for the first one, certainly you can do that quite simply. If you roll back to your days in years 8 and 9 or 7th and 8th grades, you can do this one by a sample space diagram or possibility space diagram there. All you need to do is to create a 7 by 7 grid and then work out your fractions, and then you're going to have 36 possible outcomes, and from that you can work out your values. Or you could do it by the method where we express probability as numbers between 0 and 1. You know, to do the normal fraction method. So, right, now how do we get terminating decimals, and how do we know when we get recurring decimals? Now, to have a fraction that gives us terminating decimals, the denominator has got to be either 2 to the power something, or 5 to the power something, or 10 to the power something, where n is an integer there. Okay, now do not confuse 2 to the power n as same as a number ending in 2 or a number ending in 5. Yeah, for instance, if you have 12 as your denominator, for instance, there's no guarantee that you get a terminating decimal there. Similarly, if you have a number denominator that ends in, say, 5, say 15, for instance, there's no guarantee that you're going to get a terminating decimal. Same for, say, 30, for instance. Okay, so it must be 2 to the power something, 5 to the power n, and 10 to the power n there. Right, so that means for the green die, which gives us the numerator there, that will roll out the numbers 1, because 1 is 2 to the power 0, yes, and 1 is also 5 to the power 0, so we don't need any 1 from the denominator. 2 is 2 to the power 1, which agrees with that, or 4 is 2 squared, which agrees with that, or 5 is 5 to the power 1, which agrees with that. So 1, 2, 4, and 5 are out as far as the green die is concerned. So we're left with just 3 and 6. The question then is, what is the probability of getting a 3 or a 6? Probability of getting a 3 is 1 over 6, and probability of getting a 6 is 1 over 6. If you add both, you get 2 over 6, which gives you 1 over 3 there. Okay. Now, for the blue die, now we don't need 3 because 3 over 3 will give us 1. 3 divided by 6 will give us a half, and a half is a terminating decimal. Or 6 divided by 6 will give us a 1, and 1 is a terminating decimal. So for the blue die, the numbers 3 and 6 are out. So we're not left with the numbers 1 or 2 or 4 or 5 for the blue die. The probability of getting a 1 is 1 over 6. 2 is 1 over 6, 4 is 1 over 6, 5 is 1 over 6. So the probability of getting 1 or 2 or 4 or 5 is 1 over 6 times 4, and that gives us 2 over 3. So the probability of getting a 3 or 6 and a 1 or 2 or 4 or 5 will be 1 over 3 times 2 over 3, and we get answer 2 over 9. Hope that makes sense. Right, now for number 2. Right, now for question 2, which we got here. If you roll both dice twice, what's the probability of getting a fraction given a recurring decimal at least once? So to help me explain this as well as I can, I need to draw 3 diagrams. You don't have to draw 3 diagrams. Anyway, so for the first event, I've got this here. Okay, so I've got here the probability of getting a recurring decimal on this branch here, and this is the value we had from the last slide. Okay, so we got the probability of getting a recurring decimal. Okay, and the probability of, if that's 2 over 9, so the probability of not getting a recurring decimal or a terminating decimal would be 7 over 9. Yeah, I could have put t there for terminating decimal, but it doesn't matter. So r prime is probability of not getting a recurring decimal. Right, that's for the first event. For the second event, I could do this here, and I can have 2 over 9 and for r, and then 7 over 9 for r. Or I can go down this branch here, where I can have something similar again, 2 over 9 and then r, and then 7 over 9 and r prime. So for at least one recurring decimal, you can either do go down this branch here, 2 over 9 times 2 over 9, right, as we got there, or we can do 2 over 9 times 7 over 9, because in this case we've got 2 recurring decimals. In this case we've got this one recurring decimal there, and that's what we got there. Or we can go down this route of 7 over 9 times 2 over 9, as we got there, or that's it. So if you go down this route here, there's no recurring decimal at all. So you go that way, or that way, or that way, and together all this will give us a value of 4 over 81. Okay, because that's 4 over 81, and these two occur twice. 2 over 9 times 7 over 9, 7 over 9 times 2 over 9 will give us 28 over 81, and when you add these two, you get a value of 32 over 81. Or you could say the probability of not getting a recurring decimal, which you go down this route here, will be 7 over 9 times 7 over 9, that's 49 over 81. Therefore, the probability of getting at least one recurring decimal will be all these. Yeah, that's 1 minus these. Okay, so you end up with 1 minus 49 over 81, and you should get the answer 32 over 81, and we get the same answer either method, this one or that one. Now I hope all that made some sense, and please subscribe, and thank you for watching. See you again sometime. Bye bye now.